Hello, dear students. We have been studying about the atomic mass and molecular mass of the various elements. We have even seen the atomic mass of various elements, and now we have observed that the atomic mass of chlorine was 35.5, and we came to know that it was because of the existence of the various isotopes. Same way, we can calculate the average atomic mass for the other elements even. So we have the question here: calculate the average atomic mass for carbon from the following data. We have the data given. We have the various isotopes like 12C, 13C, 14C. The relative aberrant that is directly given into the percentage is 98.892 percentage, 1.108 percentage, and 2 into 10 to the power minus 10 percentage, and their atomic mass units are clearly given: 12, 13.00335, and 14.00317. From the above data, average atomic mass of carbon that we can write according to the formula. The formula is percentage of isotope 1 multiplied by the atomic mass of isotope 1, percentage of isotope 2 multiplied by the atomic mass of isotope 2, percentage of isotope 3 multiplied by the atomic mass of isotope 3 divided by 100. So the same value we have put here, that the percentage of isotope 1 multiplied by atomic mass of isotope 1, that is 98.892 multiplied by 12, percentage of isotope 2 multiplied by the atomic mass of isotope 2, that is 1.108 into 13.00335, and percentage of isotope 3, that is 2 into 10 to the power minus 10 multiplied by the atomic mass of isotope 3, that is 14.300317 divided by 100, and by doing all this calculation we get the answer as a 12.011 U or 12.011 AMU, which is known as the atomic mass unit. So using the formula we can calculate the average atomic mass for all type of elements. Now we have the exercise question with us. Let us read the exercise question. Exercise question 1.32. Use the data given in the following table to calculate the molar mass of a naturally occurring argon isotope. So let us look at the data. We have isotope 36AR, 38AR, and 40AR. The isotopic molar mass will be 35.96755 gram per mole, or for 38AR the isotopic molar mass would be 37.96272 gram per mole, and for 40AR we have the 39.9624 gram per mole. So these are the isotopic molar mass, and their percentage are also clearly given, that the percentage for 36AR is 0.337 percentage, whereas percentage of 38 argon is 0.063 percentage, whereas the percentage of 40 argon would be 99.6 percentage. So using those percentage and the atomic masses, we can calculate the average atomic mass. We know the formula to calculate the average atomic mass. The average atomic mass of an element is equal to the atomic mass of isotope 1 multiplied by the percentage of isotope 1, atomic mass of isotope 2 multiplied by the percentage of isotope 2, and atomic mass of isotope 3 multiplied by the percentage of isotope 3 divided by 100. So by putting all this value, when we calculate, we get the answer as 39.948 unified mass U. So this is how we can calculate the average atomic mass for the various elements. We have calculated it for the carbon, we have calculated it for the chlorine, we have calculated it for the argon. Now we have the next question to study about. The question says that explain the molecular mass and formula mass with the example. So let us give the answer. Molecular mass. Molecular mass is the sum of the atomic masses of element present in a molecule. If atomic mass of carbon is 12.011 U and hydrogen is 1.088 U, molecular mass of methane, that is CH4, would be 1 into C plus 4 into H, that is 1 into 12.0111, which is the atomic mass for carbon, and 4 into 1.088, which is the atomic mass of hydrogen, and by doing the calculation we get the molecular mass of CH4 would be 16.0434. Now we want to study about formula mass. So ionic compounds, this is what methane is, a covalent compound where there is the covalent bond between the carbon and hydrogen. But some compounds are ionic compounds, so they do not have molecules but they have the lattice or crystals. Ionic compounds made up of ions have lattice. They do not exist as a discrete molecule, but they form three-dimensional lattice. For such ionic compound, instead of molecular mass, word formula unit mass or formula mass is used. Formula mass is the sum of the atomic masses of element present in the formula. So the meaning, just the word used is different, otherwise the way of calculation is same, and even the formula unit mass is the sum of the different atoms present into the formula unit. We just need to do sum for all of them. So formula of ionic compound sodium chloride is NaCl. Its formula mass would be atomic mass of sodium plus atomic mass of chlorine, that is 23 plus 35.5 U, that is 58.5 U. So now we are going to solve few of the exercise questions, my dear students. Let us solve those exercise questions into the next video. I hope, my dear students, you are enjoying your studies. Happy learning.